That's a great question, Mr. Chalongo.
I was just about to ask this.
Module 22, Probability and Set Theory, page 1193.
Not probability. Oh no.
Probability and Set Theory. Now, some of you may have seen things about this before. Some of you may have not. Those of you that are going to be taking college algebra or statistics or anything like that, this should probably help you. Yes, sir.
So apparently my book doesn't have
You don't have that one?
Remember at the beginning of the year I said there's pages missing, like, oh, you're not going to need that.
You don't have any?
You try to do your work.
I'll share. I need
I mean, I'm still gonna share with Carson, but I feel like
No, I got it.
Well, that's fine. That's fine. Some of them are like that. As long as you got it, it's fine with me. All right. Shh. Probability and set theory.
Is this the last lesson?
We're gonna. I'm hoping to get you guys into some volume stuff as well. But I think I should have enough time to do 4 or 5 lessons in this and 4 or 5 lessons in volume and surface area, just so you guys can be caught up on that kind of stuff. Probability and set theory. So we're just going to work through this, okay? We're going old school. So computers need to be down. Computers need to be down. Everyone who doesn't have a book should have a piece of paper and a pen. Now, a set. How do you spell the word set?
S-E-T.
Very good. Set. How do I denote a set? Well, I do these curly brackets. All right? So what is a set?
Is this like the matrices stuff?
It is like the Matrix.
Oh no.
I was just making a joke.
Oh, okay, good.
So, a set of silverware. You don't have to write this down, just watch. A set of silverware. We'll call that set S for silverware. What are things that you put on the table?
Nice.
Forks. Okay. Forks, knives. Anything else?
Plates. Napkins aren't silverware.
No, silverware. Shh.
On the table. Sports.
Silverware.
Spoon.
Spoon, thank you. I was just waiting for that one.
And a sport.
Okay. Forks, knife, spoon. Got it? That's a set of silverware. Does that make sense? This is a set. Okay? Set, so that's set S. Set of melons. M is our set. Watermelon.
Cantaloupe.
Don't ever say that again.
Cantaloupe.
What's the name of melon?
Anything else?
Watermelon.
Any other melon? Honeydew. Nice. Any other melons that anyone can think of?
Normal melon.
I don't know about that.
It's just
All right.
melon.
Shh. Okay, do you guys get the idea of set?
Yes.
All right. So a set, this is how a set in normal English, you'd be like, what do you set the table with? What's a set of silverware? Forks, knives, and spoon. How do we denote that mathematically? Set S equals, in curly brackets, fork, knife, spoon. Got it? Okay. What are the melons you can think of? Well, that's the set of melons. M, we'll call it. In curly brackets, watermelon, cantaloupe, and honeydew. Got it? So that's mathematical notation for a set. All right. Now, let's think about this. Here we go. Let's get a little bit more mathy with it.
Wait, what?
Mathy.
Oh, you heard him.
All right. Set. Set A is the set of prime numbers less than 10. You've got 2, 3, blank, and 7. 5. Good, yes. Now, before I did that, I should have said this. The number of elements in a set, so let me just go backwards. How many elements are there in this set? So the number of elements in set S is 3. How many elements are there in set M? 3. Good job. Listen to this. Math to English. The number of elements in set S is 3. The number of elements in set M is 3. Got it? That's how we denote it. All right. So look. Set notation. Prime numbers 2, 3, 5, and 7. 1 is not a prime number. Neither is 0. How many elements are there in set A? 1, 2, 3, 4. Got it? Yeah? Okay. Set B is the set of even natural numbers less than 10. What are those? 2, 2, 4, 6, 8.
We forgot 0.
It's not a natural number. Though it can be sometimes according to some people's definitions, but according to the book, that's not a natural number. So the number of elements in set B is how many? 4. So n parentheses B is 4. Set C is a set of natural numbers less than 10 that are multiples of 4. So what goes here in this box? C equals 4 and what's 8? Good. The number of elements in set C is 2. Good job. The universal set is all natural numbers less than 10. Okay, so we create our squiggly brackets here. 1, 2, 3, 4, 5, 6, 7, 8, 9. The N U is 9. Good. Okay? Any questions about that?
No.
Thank you. Now, generally speaking, a universal set means everything in the universe that you're specifically defining. This is saying the universal set is all natural numbers less than 10. Okay, so in this universe, that's the universal set. Okay? So sometimes that limits us. Okay? We are limited by the universe defined by that. It's kind of cool. Now, you guys get that? Set notation. Did you just learn set notation?
Yes.
S, or the set, equals the squiggly brackets separated with commas. Got it? Separated with commas. Okay, now, here we go. So, we move on here to subset, intersection, union, and complement. Now, first we start with subset. So a subset, let's say we've got a set here. A set is this whole little circle, okay? Or ellipse, okay? And I will call that set B, okay? Well, a subset of that set is within it. So I'll call that set C. This is a subset of B. Okay? And how do we signify that? We signify that with this letter, this little symbol here. It's like a sideways U. C is a subset of B. That means is a subset of. So C is a subset of B. What does that mean, practically speaking? Okay, well, B could be all the people in this classroom. So set B is everyone in this room. Okay? And then set C could be all people in this room that are math teachers. So there we go. So I am in this room, right? I'm a math teacher, I'm in this room. But so the whole set would be all of your names. but I would be here, right? So Mr. Munir's here. Bam. I never usually refer to myself in the third person, but for this example, I will. Mr. Munir, here we go. There I am. Okay? Here I am. Okay? But am I in this room still? Am I still within set B? Yes, I'm still within the room, right? But I'm in this set of my own. No one else is in this set, right? Unless you guys are secret math teachers. Okay? Does that make sense? So a subset is within the set. Okay? So another example could be like set A is all birds. Right? And set B
Toucans.
is all parrots.
No, toucans.
Right? So here's A, here's B, right? Now, are there any things that are parrots but are not birds? No. If you are a parrot, you are by definition a type of bird, right?
Parrotfish.
Oh.
Crack that case wide open.
Told you should have used the bus.
Sounds like the nut.
Okay.
Fish.
So, so get it? Here are all the parrots. They are contained within the set of all birds. Does that make sense? So it's a subset. Any other ideas of a subset, a potential subset?
Like
Use your brains.
fish
Fish.
in the
Prison.
sea
Prison.
versus parrotfish.
There you go. They're all the fish in the sea is the set, and parrotfish
That's a subset.
are the subset because they're fish within the sea. Prison.
Yep.
Okay. What about it?
Because you've got all the prisoners collectively,
Uh huh.
and then inside you've got specific like cell blocks, and then inside there you've got like the whole.
That's a subset.
There you go. Good.
Subset.
So like each cell block in the prison is a subset of the prison, right? Does that make sense? The cell block is still in the prison, but it's also a set of itself. Does that make sense? That's somewhat insensitive. All right. Shh. Intersection. Are you guys with me? Rochelle is with me.
Well,
Thank you. Good.
I'm with you.
Thank you. Intersection. Okay. I've got two sets here. I'll call this set A
Venn diagram.
and this set B. I'm going to highlight 4 regions. 1, 2, 3, and 4. Raise your hand if you think region 1 is the intersection. Region 2? Region 4?
Yeah.
Region 3? Region 3? Okay, now you guys... No, region 3. Yeah, it's region 3. Okay, see, you were enthusiastic and then I lost you. All right, so region 3 is the intersection. Got it? Okay, so let's give an example of that. This could be, let's say, student athletes, and student thespian. I was going to say thespians. Thank you, and thespians.
Spell it right, spell it right, spell it right. Yeah.
Now, I would be very impressed if there are people in here. But, so there are student athletes and there are thespians, and the people that are here are what?
Student athletes
Both.
and thespians.
There you go.
Impossible.
And that's why it's a good example, right? Because who knows anyone that's both of these?
Joseph Worsham.
no,
There you
he
go.
doesn't play sports.
He doesn't play?
He doesn't play a sport.
Oh, he just acts like he plays sports.
No.
No,
He was the
it just
basketball
plays
man.
pickleball.
No.
There you go. All right. Shh. Okay. Okay. Shh. You guys get this? Do you understand this? That's the intersection. So look, let me be a little more mathy about it. Okay. Actually, let me go back to subset for a second. Let's say I've got the set 1, 2, 3, 4, 5. Okay. I say A is 1, 2, 3, 4, 5. and C is C is the odd numbers, 1, 3, and 5. You could say that C is a subset of A, right? Because all the numbers in C are also numbers within A. Does that make sense? But you could not say A is a subset of C. A is not a subset of C because all the numbers in A are not contained within C. Does that make sense? Okay, now what about I have set A is all odd numbers
Whoa.
less than 10. All odd numbers less than 10, all positive odd numbers less than 10. And set B is all prime numbers. Okay? And then I ask you for the intersection. By the way, intersection is this right here. Just make sure I'm getting, yep. This is the symbol for intersection. It's like an upside down U. So what's the intersection of A and B? Well, it would help to get A and B first. So all odd numbers, all positive odd numbers less than 10, that's 1, 3, 5, 7, 9, right? All prime numbers, let's say less than 10 as well, just because otherwise we'd go on forever. So all prime numbers less than 10, what's the first prime number? No, 2, then 3, then 5, 7, and that's it. 9 is not a prime. Okay, now, what are the numbers that are in both? What are the numbers that are in the intersection? 3, 5, and 7. Does that make sense?
Yeah.
You see that? Now look, how would that look in a Venn diagram? Are you guys paying attention?
Yeah.
How would that look in a Venn diagram? Here's A, here's B. 3, 5, and 7 are in the middle. 1 and 9 are here, and 2 is here. You see that?
Yeah.
Does that make sense?
Yeah.
3, 5, and 7 are in the intersection. That's what this symbol means. Remember that. Okay? Now, union. You know what the symbol is for union? It's a U. Okay? That means everything within it. Okay, so if I say union of A and B, here's A, here's B. Mason, what are you doing? Here's A and here's B. Look, the union is everything. Okay? Does that make sense? Okay, so let's say we have the same sets. A is all odd numbers less than 10, so that's 1, 3, 5, 7, 9. And B is all prime numbers less than 10, that's 2, 3, 5, and 7. Putting the numbers back in, it's 3, 5, 7, 1, 9, and 2. Now, if I say set C is, look at this, set C is the union of A and B, then what is set C? What's the first number in set C? 1, 1, 2, 3, because it's all the numbers together. It's the union. Does that make sense? All right. So that's union. Now, last one is the complement. Complement. Yes. Complement. Okay? It's if this is set A, this is how you say complement. It's a C above the letter. Guys, let's focus. The complement is everything in the universe that's not in A. So it's everything out here. Okay? So let's say our universe is all numbers less than 10. And set A is odd numbers less than 10. Well, what's A complement? So set an A would be 1, 3, 5, 7, and 9 in set A, right? But what would be the numbers in my universe? My universe is here. This is my universe. All the numbers less than 10. So
2, 4, 6.
out here would be 2, 4, 6, and 8. So a complement is 2, 4, 6, and 8. Does that make sense? Yeah? All right. That's how you do it. That's how you do it. Now, with that said, okay. We move on from set stuff and we move on to calculating theoretical probabilities. All right. Sounds intense, but it's not. Probability. Probable. If I say something is probable, what does that mean to you?
It could happen.
Likely to happen.
Okay. It's cool. Likely to happen. So, depends how probable. There you go. That's interesting. That's an interesting thing to say. Probability is the percentage chance of getting an outcome. All right? So if something is highly probable, it's a high percent that it's going to happen. If it's not really probable, it's not really low percentage. So saying probable is kind of a misnomer because probability could be anything. You could have a high probability or a low probability. All right. So what is it really? Well, the probability of event A occurring is equal to this. The number of elements in set A over the number of elements in my sample space. Okay. So let's make this real. How many students are in this class?
21.
Right now? 20, I think, right? 20? 20 right now. Okay. So there's 20 students in this class. All right. Out of these students, how many are wearing blue shirts? So total students, S, is 20. The number of elements in our sample space, this is our sample space, is 20. How many people are wearing blue shirts? Okay, we got 1, 2, 3, 4, 5. No, that's black. 4, gray. Okay, 1, 2. Oh, your jacket's blue. That doesn't count. No. 1, 2, 3, 4, 5, 6, 7, 8. 8. No, they don't. Okay, so, So, number of people wearing blue shirts is 8. Number of people in our sample space in our classroom is 20, or students, right? So the probability, if I picked one of you at random, right, the probability of picking someone wearing a blue shirt is the number of students wearing a blue shirt over the number of students in my sample space, which would be 8 over 20, which I figure out the probability of that, or the percentage, it's 0.4. 0.4 is the probability. That's equivalent to 40%. So I've got a 40% chance of picking someone in this room with a blue shirt. Cool. That's probability.
Let's try it.
It's hard to pick at really random, especially because I know where everybody is. I could close my eyes, I guess. It's been around a few times. No, I'm not going to.
Do it.
We have to see math in action this year. You gotta do it. Teaching tools.
That's how we learn this, man. That's how we learn.
Okay, hold on.
Forget everything that you
Walk
saw.
out the room.
And also see.
Yeah, do like white.
What's
Spin
your
like
bag
white.
of one? It says.
Oh, your eyes No, those are apples.
Okay. Shh. All right. Look, we're going to count off the numbers. Listen, we're going to count off the numbers from 1 through 20. You have to remember your number. Okay? All right.
Eight.
14.
16.
18.
19.
20. Okay. Now listen. If your number comes up, it means you get picked. Okay? So we're going to count the number of blue shirts and not blue shirts. Okay? Does that make sense? So we're going to count the number of not blue shirts and not blue shirts. Got it? All right. Ready? Okay, who's 16? Okay, so you're not blue. All right.
Infraction.
Who's 5? Matt, he's not blue. Okay.
We gotta go until we reach 1.
3. Okay, not blue.
Dang it. It's a 40% chance. Come on, man.
15. Didn't
Not blue.
that's you, not blue again.
Got a blue jacket.
No, he doesn't. You have your colorblind.
No, we have to keep with who's 10. Nice, and she's got a blue. We got her first blue.
Yes.
All right, okay.
Yeah.
Okay, 11. That's a blue shirt too.
Blue. That's
That's
blue.
blue.
There you go. Okay,
One. Yep. Done.
nice. We got another blue shirt. Okay, 13. Another blue shirt. Oh wow, blue shirt's coming up.
You're doing this thing.
All right. 17. Who's 17? Not blue.
No, it's got blue on it.
No, it doesn't count. Shh, let's be kind. 18. Not blue. Not blue. Okay. 8. Who's 8? Oh, blue shirt. We got a blue shirt. I think I do it this way. I always forget which way I check it. That way or that way. Anyway. Shh, shh, shh. 4. Not blue.
I'm not blue.
I haven't picked yet.
Take some more students.
It's all right.
That's more blue than
We're going to go until we get to like 40 or something. 11. Who's...
That's me again.
So, blue shirt.
Let's just go to 200,000.
million.
Okay. 20. Who's 20? Oh, that's a blue one. Wow.
We got a blue one.
Okay. Shh, shh, shh. 7. Who's 7? That's not blue, right? 18. Nice. Not blue. 9. Who's 9? Not blue.
Your jacket's blue.
Okay. 13.
That's you, Solomon.
13 is you. Okay, that's a blue one. Yep.
You gotta be 16. How long overdid?
18. Wow.
That's
All right. 10. Nice.
No way. No way, dude. No.
Number's 157.
15.
That's it. I think you're lying.
I guess that's
8.
Yeah.
Again. I don't know how random this random number generator is.
Next number 17.
15.
That's me.
Why?
Why is it always
This is not the most random of the random number generators, or maybe it's just randomly picking the same ones over and over. 1. It's weird.
Yo, we're 6. This is great.
Shh, shh, shh. 3. Oh, Deborah. Not blue. Okay, I'm gonna do 5 more.
Let's get a 6.
1.
Yep. Yep.
One again.
You think so?
We're coming back.
16.
Nice.
No, we lost.
No, we're not.
3 more. 2. Is that a blue? It's blue.
Person didn't know.
3. It's Deborah.
No, we shouldn't count that one.
What is 6?
And
Yes.
number 6. That doesn't count as okay. Not blue.
Wait.
Alright.
Let's just go until we get a
I didn't count you as blue though.
Yeah, we did.
No, I didn't.
Why not?
I don't know why.
18.
Nice. Okay. Shh, shh, shh. All right, now let's count them. Look. Shh, shh, shh. I don't know why. Look, there were 13 blue, and there were 18 not blue. So how many were there in total? How many were there in total?
Whatever 8 plus
47.
31. Okay, so the probability of blue came out to be what? 13 out of 31, right? So let's figure that out.
That's like 40%.
42%.
Oh.
Whoa, that's pretty close. Yeah, we can clap it up for math. Good job. Okay. All right. So class, let me ask you something. If I kept picking more and more and more, would it get closer or farther away from us? Closer. The way that probability of random events occurs is that the more times you pick, the closer it gets to the exact probability.
Alright.
Right? If I just picked one, like then it would be super far because it would be like 100%
Wait, what if
blue,
I
100%
say,
not
what
blue.
if I say I don't believe you and you have to prove it?
You can't
You
prove
would
that.
say, nah.
It's just it's just induction. I guess you could probably prove it. You could probably
Let's
prove
do
it. No,
Prove to me that the number gets closer. I want to see it.
that sounds too demanding. All right, now. All right. Quiet, quiet, quiet. You roll a number cube. Look, okay. You roll a number cube. Event A is rolling a prime number. Event B is rolling an even number. So your total sample set is S, which is 1 through 6. You see? Event A is 2, 3, and 5. There are 3 elements in A. And so the probability of A is 3 over 6, which is 1/2. So the probability of rolling a prime number is 3 over 6. Does that make sense?
Yeah.
Okay. All right. Now, A union B is everything in A and B. Well, B is all even numbers, right? So set B would be 2, 4, and 6. So it would be 2, 3, 4, 5, and 6. So A union B is 2, 3, 4, 5, 6. And there are 5 elements in there. So the probability of rolling, and this is the key, the word is or, all right? With union, it's or. So I say, what's the probability of rolling either a prime number or an even number? Well, the probability of rolling a prime or an even is the union, which is 5 over 6. Does that make sense? Okay. If I say or, right? What's the probability of rolling either a prime or an even number? The answer would be 5 over 6 because both of those things could be possible. The only one that wouldn't give me a yes is if I rolled a 1 because that's not prime nor is it even. Does that make sense to you?
Yeah.
So union is like or. Now, A intersection B is like and. What is the probability that I roll a number that's both prime and even? Well, the only one that's both prime and even is 2. 2 is the only even prime number, right? So there's only one of those, so the probability of rolling a prime even number, something that's both prime and even, is 1 out of 6. So intersection, the keywords there are both and. Does that make sense? So it's both prime and even, whereas union is or. Does that make sense? So it could be either this one or that one, and both of them work. Now, A complement. A complement. If A is the prime numbers 2, 3, and 5, then A complement is the ones that are prime, 1, 4, and 6. There are 3 elements in A complement, so the probability of rolling a number that is not prime, and the key word with complement is not. Does that make sense? Not prime is 3 out of 6, which is 1/2. Does that make sense? So what are the keywords I just gave you? Okay. So union, this is union. The key word is or. Intersection, the key word is, or words are both and. And then complement, the key word is not. All right? Now, with that, go ahead and work on this. Go ahead and work on this. Example B. And if you don't have your book, just use paper and take a look at it. Go ahead and work on that and just fill them out. Let's do it together. Okay, your grocery basket contains one bag of each of these items. This is so fun. It's like shopping in math class. Okay. One bag of each of these following items: oranges, green apples, green grapes, green broccoli, white cauliflower, orange carrots, and green spinach. You're getting ready to transfer your items from your cart to the conveyor belt for checkout. Event A is picking a bag containing a vegetable first. Okay? Event A says, I'm going to pick something. Event A says, I pick a vegetable. Got it? Event B is picking a bag containing a green food first. So event B is, I pick a green food. Okay? All bags have an equal chance of being picked first. Here's my sample set: orange, apple, grape, broccoli, cauliflower, carrot, spinach. So NS is what? 7. Good. Event A is a bag containing a vegetable. So it's broccoli, cauliflower, what else? Carrot, spinach. Very good.
Kale.
Tomato.
There's no kale here. And tomato is not a vegetable. Now, the number of elements in A, it was a tough one. I liked it though. Element, bring it in. So, the number of elements in A are, how many? 4. So the probability of A is the number of elements in A over the number of elements in our sample space, which is 4 over 7. Cool. You see how math helps us out?
Yeah.
All right. Now, A or B?
D.
Okay. A or B. Union. When you see this, you should make the hand signals. Union. There you go. Nadia just did it perfectly. That makes me very happy. Okay. All right. Union B. All right. What does that mean? That means in everything that's in A or in B. All right. Now, here's the one element that I don't like about this. They don't give us B first, so let's get B by itself. Let's just, in our little thing, create B, because it just helps us. So B is picking a bag containing a green food. Okay, so orange is not included. What about the apples?
Red apples? No, they're green apples.
It says green apples, so green apples.
Broccoli. Wait.
Yeah, that's included. But let's do it in order. So it's apples, then grapes, then broccoli, and then spinach. No, event B is picking a bag containing a green food.
You ever seen colored carrots?
Yes, heirloom.
Really? No, they're like blue potatoes.
Yeah,
It's a real
I've
purple
seen-
potatoes.
I've seen the purple apples that taste like grapes.
It's crazy.
Now you're just.
All right. Shh, 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 shh. So A union, woohoo. A union B. A union B is all the things in A and all the things in B. Okay? So that includes broccoli, cauliflower, carrot, spinach, and that's it for A. So now I move on to B. And I don't write it twice, but I've got apple, and then grape is right there. Do I write broccoli and spinach again? No, because it's already there. Okay? So the number of elements is 1, 2, 3, 4, 5, 6. Good. So the probability, what this is in English is the probability of picking a green food or a vegetable first, or the probability of A union B is the number of elements in A union B over the number of elements in my sample space, which is 6 over 7. Okay? So that's the probability of picking a green food or a vegetable. Okay? Now, A intersection B, how would I say that in English? A is green food, or A is vegetable, B is green food. So A intersection B, how would I say that in English? What's the key word with intersection? And. both and, right? So it's the probability of picking something that is both a vegetable and green. So in English, it's the probability of picking a green vegetable. Does that make sense? So which of these are green vegetables? Which of these are in both? Broccoli and... Very good. So the number of elements in A intersection B, or the number of green vegetables, is 2. So the probability of A intersection B is the number of elements in A intersection B over the number of elements in my sample space, which is 2 over 7. Does that make sense? Okay. There we go. Okay, is there another one? Just scroll down a little bit. Okay. I don't know what that's asking for. Oh. Okay. What about the probability, class? What about the probability of picking something in A complement? That's everything that's not a vegetable, right? So that would be an orange, an apple, a grape, right? So how many elements? So it would be number of elements in A complement over the number of elements in my sample space. How many elements are there in my A complement? 3. So it's 3 over 7. Does that make sense?
Yes.
Okay. So this gives us a good idea of how to do these kinds of things.
Awesome.
And probability. You have ability and probability. Oh. Okay. Thank you. All right. Now, with that, I think we're good. We could continue, but I think that you guys have the general idea.
Yeah, we got it.
Oh, no. There's one more thing. Look at this. The probability of A, we said, was 4 over 7. Probability of A was 4 over 7. Just take a look. What was the probability of A complement? 3 over 7. Look at this. The probability of A complement. What do I notice about these two? 4 over 7 and 3 over 7.
They add up to 7 over 7.
Which is?
1.
So the probability of A complement is 1 minus the probability of A. You see that?
Wow.
Because the probability of A complement is 3/7 equals 1 minus 4/7, or 7 over 7 minus 4 over 7. So did I have to go through the work before to get the probability of A complement? No. Once I've already got the probability of A, I can get the probability of A complement directly by subtracting it from 1. Does that make sense? The same is true conversely. The probability of A equals 1 minus the probability of A complement. Does that make sense? Okay. So what's the easiest way to think about this? Probability of A plus the probability of A complement, they equal 1. They add up to 1. See? Does that make sense? All right. So with that, you go on to your homework. Your homework is just regular homework now. What? Okay. Your homework is numbers 1 through 25 odd. 1 through 25 odd.
I have some sheets taken out. Mine is your Yeah.
All of it?
Homework.
Okay, you're gonna have to go online.
I mean, some questions. It starts with
I'm sorry. You can go online and just do it on sheet.
where do I find that?
It's on the Holt McDougall that you probably haven't been on since the beginning of the year. Okay. Hold on. Who has pages ripped out of their homework? You too? Anybody else? No, don't just raise your hand.
Just take a picture and send it to Kaiser.
No, I'm gonna print it out for you right now.
Wait, huh?
You know what?
Okay.
Like, oh, think about it.
That's really difficult. I'm not doing that ever again. That would really be hard. To do this.
It's all. That's right. You just got it.
Do that.
Okay, so the homework is page 1200, numbers 1 through 25, odd. What's the probability of, just kidding. That's it, good job class.